Okay, so I'm going to have a look at one or two of the homework questions. I did get a request to talk in more detail about the reference angles. Okay, so we're turning this into polar form. So the first thing I'll do is draw a little I plot on the Argand diagram. Okay, so minus 4 plus 4i, so that's length 4, and this here is length 4 as well. Now it's minus 4, but it's length 4. Okay, now this is going to be my reference angle. Okay, and then this is going to be the argument. Okay, so that's the theta, that's the argument that goes into the polar form. Okay, so we're going to use to find this reference angle here, it's this right angle triangle, and we're going to look for this angle here. Now this is 4 and 4, so we're using tan. So it's tan alpha is 4 over 4. Don't worry about the signs, just deal with the lengths at the moment. So alpha is tan inverse of 4 over 4, which is 1. Now, you want your calculator in radian mode. Sorry, I've been dealing with second years, so I had it back in degrees. So tan inverse of 1 is, now I know it's 45 degrees anyway because it's 4, 4. So it's pi over 4, which is 45 degrees. Now, that means what is the argument? Well, the argument then is it's not a full pi, it's not 180 degrees or pi radians, it's pi radians, take away the reference angle. So it's 3 pi over 4. The next thing I need to do is find the modulus, or which is this length here, and I just use Pythagoras' theorem. So it's the square root of 4 squared plus 4 squared, which is root 32, which is 4 root 2. Yep. Okay, so now to put it all together into polar form. So minus 4, apologies, plus 4i is, or, which is 4 root 2, times cosine of the argument, which is 3 pi over 4, plus I sine of the argument, which is also 3 pi over 4. Okay, so that's that question. Now, if it's in this quadrant here, it's just the reference angle is the angle. Okay, the argument is just the reference angle. Now, if you look at question 3, I minus root 3 minus I, if it's down in this quadrant here, that's down here, so minus root 3 and minus 1, okay? If it's down there, this is going to be our argument, and it's going to be negative because we've gone anti-clockwise. So it's a little bit different to unit circle, where unit circle we always went the whole way around. Here, we wanted it to be less than pi, between 0 and pi, or between minus pi and 0. So it's between minus pi and pi, really. So this is my reference angle, okay? So again, to find my reference angle, I'm going to use tan. So tan, the reference angle, opposite 1 over adjacent root 3. I'm not going to take the negatives. Okay, I means it's 1. Okay, I'm not going to take the negatives because it's the lengths I'm looking for to get the angle. Okay, so tan inverse of 1 over root 3 is, these are all in your tables book anyway, just don't have mine to hand. is pi over 6. Okay. So now to find the argument, okay, this would be, if I got the whole way over, it would be negative pi. So it's minus pi plus whatever this is. So plus pi over 6. So it's minus 5 pi over 6. So that's my argument. Okay. My modulus then is the square root of 1 squared plus root 3 squared, which is root 10. Okay, root 10. So then minus root 3 minus I is or, which is root 10, by cosine of the argument, minus 5 pi over 6, plus I sine of the argument, which is minus 5 pi over 6. Okay. And that's the same. So it's the same if I did it this way. Okay, if I had, I'll just show, so for question 4, when I'm looking for the reference angle here, it's just minus whatever my reference angle is, theta. Okay, minus my reference angle is theta. Okay, if it's in the third quadrant. Okay, so that's from the homework. That's the only request I got, so I presume the rest of it was fine. So for multiplying and dividing, I'll do the first one of 10, which I asked you to do. So that's 5 by cosine, sorry. So it's 5 cosine pi over 3 plus I sine pi over 3 times 2 cosine pi over 6 plus I sine pi over 6. Now, you can go back to the previous page and look at the proof. Okay, that's the proof. You could turn these into rectangular form. So put these into x plus yi, multiply it and then turn it back. But really, all we need to do is multiply 5 by 2 as that's our new modulus. And then I have cosine of the arguments added. And I sine of the arguments added. So I end up with 10 times cosine. Now pi over 3 plus pi over 6. Imagine this is 2 pi over 6. So 3 pi over 6. So that's a half. So it's pi over 2 plus I sine pi over 2. Okay, division is the same, except we divide and subtract. Okay.